This video builds upon another video of mine where I demonstrated how to save a data frame as a PDF using the pandas and matplotlib libraries in Python. I won't be going into too much detail on how to actually save the PDF, but if you're interested in checking out how to do it, click on the link at the top of this video or the link in the descriptions. The code on the screen is the exact same code from that previous video on how to save a data frame as a PDF, with a variety of lines commented out. Everything that is commented out is new for this video and will demonstrate how to add context to your data frame that is being turned into a PDF. The data frame I'm working with in my video is just a random assortment of numbers. Scrolling up, you can see how it's created. I'm using the DataFrame function and passing it the rand function, specifying 25 rows and 5 columns. Very briefly, let me go over the uncommented code from the original video. I opened up a new PDF document called PDF test, and I set the figure size with the subplots function. I turned the axis off so it's not displaying on our sheet, and I created the table with the table function on the axis object. I then finally saved the PDF with the savefig function. Let's just run this through to show what the output is without any of the added context I would like to add. And opening up the PDF, we can see we have our data frame nicely displayed on the sheet. So let's start by adding some text to the top of our PDF. This will allow us to give the data frame a nice title and context onto what is actually being displayed. For this, all I have to do is uncomment this fig.subtitle function line, where I am passing "this is my data frame" as a title and assigning it a font of size 16. Executed, you can now see the output below. Let's also open the PDF to see what it looks like. Now we have ourselves a title. Let's say that we also want to add the date that this data frame was created. Let's comment out this first line and uncomment both this import at the top and the next line where I have accessed the now method of the datetime library and transform the display to show the year, month, and day that this data frame was produced. Again, we can see our output below, but let's also open our PDF. At the top, we can see our expected output of our title and our creation date. Now let's work with some images. Let me uncomment this last import at the top, which imports the image read function of the matplotlib image module, this image variable line, which uses the newly imported image read function to read in the Python logo PNG contained in the directory over here. And finally, these last 3 ax image lines of code. Within the creation statement, I declare a variable axImage to be a rectangular area on the figure. I accomplish this with the figuresaddAxes method and pass the rect argument a tuple of 4 numbers. More on these numbers shortly. To add the image to that area, I access the figure object's image show function and pass it the image I created with the image read I used earlier on. I turned the axis off on our axImage object for the same reason that I turned it off on our data frame. It would not make sense to see the axis show on our image. Let's run this code and see what is produced. And check that out. We now have a Python logo displaying underneath our title. Let's open up the PDF to see what it looks like. It is not quite center, but you can see what I am aiming for. Back in Jupyter Labs, let's talk through this image creation process. What actually has to happen is you first have to define the location and rectangular box size of the image before you add it to the sheet. That's where this line of code comes into play. Let's open up the docstring for add axes. Here is the rect argument and what each item in the tuple signifies. Left is how far from the left-hand side the image will be displayed. Bottom is how far from the bottom. Width is how wide the image is, and height is how tall the image is. Let's play around with some of these to show how it works. Instead of 0.4, let's set my left to be 0.9. The image is thrown all the way to the right-hand side of my PDF and actually extends beyond the bounds of the table. Opening up the PDF, you can see it actually crops the image out. So let's return this back to 0.4. Now let's get the bottom to be assigned 0.1. Scrolling all the way down, we can see the Python image now displaying at the bottom of our PDF. Opening the PDF, we see the same output. Let's return this back to 0.85, and now change the width to be 0.1. Now the image has shrunken. So let's move that back to 0.3, and finally let's affect the height, changing it to 0.9. Now the rectangular area in which we've placed our image is extremely large, much larger than we need it to be, and it's actually pushed the data frame down on the page. Opening up our PDF, you actually can't even see the image anymore, as the parameter I passed effectively made it fall off of the page. So it's worth exploring the parameters here for your image and use case. It will require a bit of testing to get it just right. But overall, it is quite straightforward to add some text and an image to the PDF of your data frame. For text, just access the subtitle and pass it whatever text you want to be displayed. For the image, it requires a bit more work, but all you have to do is define your rectangular area in which you want an image placed, and then to your figure, you want the image to be shown. Thank you for watching. Let me know in the comments down below if this was a useful and informative video. Do give it a thumbs up if you liked it, as it really does help others find this content. And don't forget to hit subscribe so that you know when the next video drops.